Okay, here we're looking at direct variation. Okay, direct variation. I'm going to give you some examples of direct variation and see how they play out. So, direct variation. So suppose I say volume varies directly with time. So imagine yourself if you're filling out your bathtub, okay, and the volume of water this water is pouring into your bathtub, and the volume of that water is going to increase over time. As time increases and the water continues to pour into the tub, the volume increases. So when both volume and time increase, they call that direct variation. And we would write this in the following fashion. Whatever's on the left side varies directly is on the left side of the equation. So you go volume equals KT, where K is your constant of variation. Okay? Pressure varies directly with depth. Imagine that you're diving into the swimming pool, and as you go deeper and deeper, the pressure against your ears increase. Okay? So as the depth increases, your pressure increases. We would write this as pressure equals KD. Okay? Well, again, with this constant of variation. Age varies directly with time. I am older today than I was yesterday. As time marches on, so does my age. So we would go age is equal to KT. Okay, as age varies directly with time. Grades vary directly with time spent studying. The more time that you spend studying, the better your grade's going to be. So we go G, K, T. Okay, these are all equations of direct variation. All right, and every single one of these, they have a constant of variation. So here we go. Suppose I'm given the equation volume varies directly with time, and I'm given that I am filling a tub up and it's filling up at a 1.5 gallons per minute. How long will it take to fill a 45-gallon tub? Well, I'll stop and think about it. So I'm given a time and I'm given a gallons. So I need to plug this into this equation and find out what my constant of variation is. So I go 1.5 is equal to K, how many minutes? Per minute. So it's 1 minute. So to find my constant of variation, I simply divide both sides by 1. And I find out that my constant of variation is 1.5. So that is my K. So now I've got a formula, and I'm going V is equal to 1.5 times time. Well, how long will it take to fill a 45-gallon tub? All right, well, I know my gallons are 45, so I'm going to replace the volume with 45. And that's equal to 1.5 times T. Solve for T. What am I going to do to both sides of the equation? I hope you're going to tell me you're going to divide both sides of the equation by 1.5. So here I go. I got 45 gallons divided by 1.5. 45 divided by 1.5, I think is 30. I know it's 30. So my time is going to be 30 minutes. That would be my answer to that question. Now, another method you could use to solve this would be through equivalent fractions. So I could do this. I could say 1.5 gallons per 1 minute is the same as 45 gallons is per X minutes. So I have equivalent fractions. When you have equal fractions, you can cross multiply. That's called cross products. So we would do this. We'd go 1.5 times X is equal to 1 times 45. So 1.5x equals 45. And again, I would divide both sides by 1.5 to find out what that x is. Gee, doesn't that look familiar? And again, we come out with x being equal to 30. Either way, you get the answer. That's direct variation.